What are the other five vulnerabilities that are mentioned in the OWASP document and its API security project guidelines? And what are their prevention mechanisms? Let's explore. The next one is mass assignment. So, mass assignment is a typical vulnerability that comes when you bind the client provided data to data models without proper properties filtering, either guessing object properties, exploring other API endpoints, reading the documentation, or providing additional object properties in request payloads, allow attackers to modify object properties they are not supposed to. How we can prevent this? If possible, avoid using functions that automatically bind a client's input into code variables or internal objects. Whitelist only the properties that should be updated by the client. Use built in features to blacklist properties that should not be accessed by clients. If applicable, explicitly define and enforce schemas for the input data payloads. The next common vulnerability is security misconfiguration. Security misconfiguration is commonly a result of unsecured default configurations, incomplete or ad hoc configurations, open cloud storage, misconfigured HTTP headers, unnecessary HTTP methods, permissive cross origin resource sharing, and verbose error messages containing sensitive information. So, how you can prevent this vulnerability? The one way is to know that your API lifecycle should include a repeatable hardening process leading to fast and easy deployment of a properly locked down environment, a task view to review and update configuration across the entire API stack, a secure communication channel for all API interactions, access to static assets like images, an automated process to continuously assess the effectiveness of the configuration and settings in all environments. That's what the document suggests. And additionally, it says that to prevent exception traces and other valuable information from being sent back to attackers, if applicable, define and enforce all API response payload schemas, including error responses. But if that is possible, if you have an exhaustive application, probably that's not possible. Ensure API can only be accessed by the specified HTTP verbs. All other HTTP verbs should be disabled, like head. APIs expecting to be accessed from browser based clients should implement a proper cross origin resource sharing policy. The next one is injection. Injection flaws such as SQL, NoSQL, command injection, etc., occur when untrusted data is sent to an interpreter as part of a command or query. The attacker's malicious data can trick the interpreter into executing unintended commands or accessing data without proper authorization. The interpreter here is the API that we use. So, how we can prevent this vulnerability? Preventing injection requires keeping data separate from commands and queries. Perform data validation using a single, trustworthy, and actively maintained library. Validate, filter, and sanitize all client provided data or other data coming from the integrated systems. Special characters should be skipped using the specific syntax for the target interpreter. Prefer a safe API that provides a parameterized interface. And always limit the number of return records to prevent mass disclosure in case of injection. Validate incoming data using sufficient filters to only allow valid values for each input parameter. And finally, the document says define data types and strict patterns for all string parameters. So, these are some of the common mechanisms through which we can prevent the injection vulnerability in our APIs. The next common type of vulnerability that can occur in an API is improper asset management. Because of improper asset management, APIs tend to expose more endpoints than traditional web applications. So, making proper and updated documentation is highly important. Proper host and deployed API versions inventory also play an important role to mitigate issues such as deprecated API versions and exposed debug endpoints. And for this, the document suggests that you inventory all API host and document important aspect of each one of them. Inventory integrated services and document important aspects such as their role in the system and what data is exchanged and its sensitivity. Document all aspects of your API such as authentication, error, redirects, rate limiting, cross-origin resource sharing policy, and endpoints, including parameter requests and responses too. Generate documentation automatically by adopting open standards that are available. Include the documentation built in your CI/CD pipeline. Make API documentation available to those authorized to use the API. Use external protection measures such as API security firewalls. And avoid using production data with non production API deployments. If this is unavoidable, then these endpoints should get the same security treatment as the production ones. And also, it is important that when newer versions of APIs include security improvements, perform risk analysis to make the decision of the mitigation actions required for the older version. And the last and important point is insufficient logging and monitoring. That also cause the API security risk. Insufficient logging and monitoring, coupled with missing or ineffective integration with incident response, allows attackers to further attack systems. And most breach study demonstrate, as per the document as well, that the time to detect a breach is over 200 days, typically detected by external parties rather than internal processes or monitoring. So, how we can prevent this kind of vulnerability in our API? The one way is that you log all failed authentication attempts, denied access, and input validation errors. Log should be returned using a format suited to be consumed by a log management solution. Log should be handled as sensitive data and their integrity should be guaranteed. Configure a monitoring system to continuously monitor the infrastructure, network, and the API functioning. Use security information and event management system to aggregate and manage logs from all components of the API stack and host. Configure custom dashboard and alerts enabling suspicious activities to be detected and responded to earlier. So these are some common vulnerabilities or flaws in our API design and use that often open the gates for security challenges. By keeping these prevention mechanisms mentioned in the document in mind, we can develop secure APIs. For more information on this, you can visit OWASP's website, owaps.org, and can locate their project API security. And finally, I would say that remember, API security means protecting the APIs, both the ones that you own and the ones that you use.